Cosmic Shockwaves 2025's most astounding NASA revelations. Welcome to our channel. Today, we're diving into the top 3 NASA discoveries in 2025 that shocked scientists. Stay tuned because number 1 will make you question everything we know about the universe. It's a universe that, time and time again, proves to be more inventive, more surprising than we could ever imagine. We, as a species, are explorers by nature, driven by an insatiable curiosity to peek behind the cosmic curtain. And every so often, what we find there isn't just a new star or a distant galaxy, but something that fundamentally rearranges our understanding of the very fabric of reality. These aren't just incremental steps forward. These are leaps into the unknown, moments where the textbook pages feel suddenly thin and incomplete. The year 2025, it seems, was particularly generous in serving up such cosmic conundrums. NASA, with its ever-probing eyes and ears pointed skyward, found itself at the epicenter of these revelations. The data streamed in, initially perhaps as puzzling anomalies, then as persistent enigmas that refused to fit neatly into our established frameworks. What we're about to explore are not just discoveries, but invitations to think bigger, to question deeper, and to embrace the profound mystery that still envelops us. So, buckle up your intellectual seatbelts. We're about to journey to the very edge of current knowledge where the familiar laws of physics seem to fray and new, unimagined possibilities emerge. These are the findings that sent ripples of astonishment through laboratories and observatories worldwide. The kind of discoveries that remind us that the cosmos is under no obligation to make sense to us. But it is our privilege, our driving passion, to try and make sense of it anyway. Let's get started. Kepler 707b, the planet with an atmosphere that rewrites the rules. Our first stop is Kepler 707b, an exoplanet orbiting a distant star, initially flagged for its peculiar transit signature. At first glance, it seemed like just another gas giant, but as data accumulated, a picture emerged that was anything but ordinary. This wasn't just another dot in the cosmic census. This was a world behaving in ways that made atmospheric physicists scratch their heads. The primary anomaly concerned its atmospheric stratification. Typically on planets with substantial atmospheres, we see layers defined by temperature and pressure gradients. Kepler 707b, however, decided to throw that textbook out the nearest airlock. Its upper atmosphere showed an unprecedented density of heavy metallic vapors, suspended as if by some unseen force. Imagine a planetary atmosphere where elements like iron and titanium are found in abundance, forming shimmering, reflective clouds at altitudes where they simply shouldn't exist. This isn't just a little bit odd, it violates our fundamental understanding of atmospheric dynamics. Scientists initially suspected sensor malfunction. Could the Cosmic Breath Observatory's advanced spectrometers be miscalibrated? Rigorous cross-checks were performed. Data from other ground-based and spaceborne assets were correlated. The signal was robust, the observations consistent. The planet was indeed hosting this baffling atmospheric phenomenon. The implications are profound. What mechanism could possibly support such a structure? Early hypotheses ranged from incredibly powerful planet-wide magnetic fields to some exotic form of radiative pressure from its host star. Each theory, however, comes with its own set of challenges. Consider the energy requirements. To keep such massive quantities of heavy elements suspended so high, you'd need an energy source of unimaginable scale. The weather patterns are equally perplexing. These metallic clouds don't just sit there, they appear to shift and swirl, creating weather systems unlike anything theorized. This discovery forces us to reevaluate our models of planetary formation and atmospheric evolution. How does a planet even acquire such an atmospheric composition? Did it form in a protoplanetary disk, unusually rich in these heavy elements? The scientific community is now abuzz with proposals for follow-up observations. We need more detailed spectral analysis across a wider range of wavelengths. The James Webb Space Telescope's successors are being tasked with dedicating significant observation time. It's a humbling reminder, isn't it? Just when we think we're getting a handle on the diversity of worlds out there, the universe throws us a curveball, like Kepler 707b. It's a planet that doesn't just add to our catalog, but actively challenges our understanding. The quest to understand Kepler 707b is pushing the boundaries of our observational capabilities and our theoretical models. It demands new ways of thinking about planetary science. The Cosmic Whisper, a signal from the depths of space and time. Our journey takes us to a signal designated Whisper 25, detected by the Pan-Galactic Array. It wasn't a sudden burst or a regular pulsar, it was different. The signal had a complex mathematical structure. It was persistent, coming from a distant patch of sky. The team ruled out terrestrial interference. Its characteristics were unlike any known astrophysical models. The search is on for other similar signals. Whisper 25 remains an enigma, a cosmic question mark. The silence of space might not be so silent after all. Chapter 3. The Kronos Anomaly. A mission's unexpected brush with space-time itself. Our final discovery from NASA in 2025 came from much closer to home, during a mission intended to test advanced propulsion systems. The mission, codenamed Pathfinder Deep, involved an uncrewed probe venturing into the Kuiper Belt, and it stumbled upon something that has physicists re-examining the very nature of space and time. The Pathfinder Deep probe was equipped with a suite of next-generation sensors. Its primary mission was to test a novel plasma magnet drive system. Everything was proceeding nominally for the first few years of its journey. Then, as Pathfinder Deep passed through a particularly empty region of the outer solar system, its highly sensitive navigation system began to report discrepancies. Tiny, almost imperceptible at first, but consistently. The probe wasn't quite where it was supposed to be. The discrepancy was in its temporal readings as well. The onboard atomic clocks showed deviations that couldn't be explained by standard relativistic time dilation alone. This was dubbed the Kronos Anomaly. The probe seemed to be experiencing minute, localized fluctuations in the passage of time. These weren't violent distortions, but rather a kind of space-time weather, something that, according to Einstein's general relativity, simply shouldn't be happening. The initial reaction was to suspect instrumental error. Every system was remotely diagnosed, recalibrated, and cross-checked. The anomaly persisted. It seemed to correlate with the probe traversing specific volumes of space. What made the Kronos Anomaly particularly shocking was that these space-time lulls and surges were not associated with any detectable mass or energy concentrations. General relativity tells us that gravity is the curvature of space-time caused by mass and energy. If space-time is being locally flexed or warped in these empty regions, what is causing it? One hypothesis is that Pathfinder Deep might have detected evidence of extra-spatial dimensions. Another explores the possibility of vacuum energy fluctuations manifesting on a macroscopically detectable scale. The data showed that as it entered one of these anomalous regions, its onboard clocks would minutely speed up or slow down. These effects were tiny but measurable and patterned. The implications are staggering. If space-time can have these intrinsic localized weather patterns, it could affect everything from interstellar navigation to our understanding of the universe's expansion. The mission, originally designed to test propulsion, has inadvertently become a fundamental physics experiment. NASA is already considering follow-up missions to map these space-time anomalies with greater precision. The Kronos Anomaly is a profound reminder that even in our own cosmic backyard, there are fundamental mysteries waiting to be uncovered. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. What do you think about these discoveries? Let us know in the comments below. From the bizarre atmosphere of Kepler 707b defying known physics, to the enigmatic Whisper 25 signal hinting at unknown cosmic processes, or perhaps something more, and finally, the Kronos Anomaly suggesting that space-time itself is more complex than we ever imagined. 2025 truly was a year that pushed the boundaries of our understanding. These discoveries underscore a fundamental truth about science. The more we learn, the more we realize how much we don't know. Each answer often unearths a dozen new questions, each more profound than the last. And that's the beauty of it. It's a perpetual journey into the unknown, driven by human curiosity and our relentless quest to comprehend the universe and our place within it. These NASA findings aren't just headlines, they are invitations to wonder, to explore, and to participate in the grand intellectual adventure of our time. So keep looking up. Keep questioning. The universe is under no obligation to make sense to us, but it is our distinct privilege to try. The cosmos is vast and its secrets are deep, but with every new observation, every new theory, every shocking discovery, we peel back another layer, getting ever closer to the underlying truths that govern all of reality. The journey continues, and the next great revelation might be just around the cosmic corner.